so that we know what we're doing here. So take a look here. It says the curve at right is drawn in the XY plane. I think this is a pretty good indicator of what you need to do with graphing. This graph is given to you simply because it just makes it a little more reasonable, a little more, you can get to the good stuff quicker. It tells you the equation is theta plus sine of 2 theta for the interval 0 to pi. Can you see the interval of 0 to pi showing up on the graph?
Yes.
Maybe you can see how the radial line would start off facing that away. And when it's facing that way, the radius length would be 0, wouldn't it? Mm-hmm. And it's just going to rotate all the way through to here. And as you rotate all the way across from 0 to pi, you're going to get varying lengths. The radius will be this long, then that long, then that long, and so on and so forth. We'll actually look at those lengths here in a little bit. Let's see here, thetas and radians. They give you they're nice enough to give you the derivative r, not like it would have been that hard for you guys to find. DRD theta right there. Part A just jumps right in. This is the stuff we've been working on. Find the area bounded by the curve and the x-axis. Keep in mind that the calculator's active, so please take a minute, set this up. I'm hoping that this will be a pretty straightforward one for you based on all the work we've been doing with area. Give it a shot. A, that once you got things set up, you probably used Math 9. I think that would be logical. So let's make sure your setup is good. I would say for this one, the area would be 1/2 integral from 0 to pi of r squared. So that would be theta plus sine of 2 theta, quantity squared d theta. So remember, it's 1/2 integral of r squared d theta. And so I mentioned a second ago, Math 9 would be the thing here. So you don't really even have to be in polar mode, right? You could just use an input of x here. Since radians are unitless, it really doesn't matter. Did anybody come up with an approximate answer for this one? 4.3823. 3823. Agreed? Okay. Fair enough. So I'm hoping that all this area stuff is coming together for you and you're feeling more and more comfortable. Remember, these are just sectors instead of rectangles, and we rotate the sector through the region. Any questions on A? Okay, B. B says, find the angle theta that corresponds to the point on the curve with the x-coordinate -2. So x-coordinate -2 is what we're trying to match there. So again, give you a couple minutes here to try to get this one going with this. So it says find the angle theta that corresponds with the x-coordinate -2. So first of all, here is the x-coordinate -2 right there. Oops, something like that. So you can see that theta is going to be, I don't know, something like that, whatever that angle is. That make sense? So we just need to find what it is, and we can't just take a guess. So here's what I would do. Remember, the x-coordinate on a polar curve can be expressed by x is equal to r cosine theta. And so I'm going to say then that -2 equals theta plus sine of 2 theta cosine of theta. So if you guys are doing okay, I'm guessing you probably have that equation written down. Does that make sense? Okay. So here's the thing that I want you to get, and this is kind of a tricky transition because walking around looking, you guys are all in polar mode in your calculator trying to find intersections, and we definitely want to be finding intersections or using our calculators to do this. I want to remind you though, this right here, that's an x-coordinate, is it not? Mm-hmm. This over here is also an x-coordinate. So what I would do, if I were you, is I would go back to rectangular mode. And I would graph one graph, like y1 would be -2. And the other one would be theta plus sine 2 theta cosine theta. The thetas are going to show up as x's. We want to realize that the x's in the calculator are actually going to be the thetas in our problem. But you can just, because those are both x's, you could just use rectangular mode and find out where those two graphs intersect in rectangular mode, at least between 0 and pi, since that's the domain for this one. And that should work out okay. That's always a challenge, right? Because you're so used to being in polar mode and there's thetas and everything, and making that transition over is tough. So anyways, once you think you got an answer, it's looking at the graph, it's got to be between pi over 2 and pi, right? So if we come up with something other than that, then we got a problem. Check it out.
So you got -2, then you got the 2x plus sin 2x times cosine x. And you find the intersection of them, those two intersect between 0 and pi.
So like when you set up your window, that'd be where you'd handle the 0 and pi. So I see an intersection point just about to happen. Come on, you can do it. They're getting closer. There it is. That'd be depressing if that curvy one was like, nope. Come on, I thought it was going to do it. Okay, so Caleb, you got one?
Yeah.
What do you got?
2.786.
2.786. So that definitely fits the domain that the graph seemed to indicate, right?
Mm-hmm.
Because the graph was saying between pi over 2 and pi, and that's definitely between pi over 2 and pi. So that definitely is a logical answer. Are you guys coming up with the same thing?
Mm-hmm.
Okay. Good deal. Any further questions? I feel like you guys raced off and you got here pretty quick. At least a lot of you did. You're like, oh, cool, convert over, I got it. Now what, right? So the calculator, getting that gap with the calculator filled in, I think was hopefully good. Okay, if you haven't already started looking at C, please do. C is really just a conceptual explanation. I don't think there's any real calculating of anything to be done there. So try that one out.
Which means, what does it say about the thing? Which means it's heading back to the origin.
The first one is, what does this fact say about R? So if drd theta is negative, anybody want to offer up? What does that mean about R? R is decreasing, yeah. So that would be a good explanation. Since the rate of change of R is negative, that means the length of R is decreasing. Makes perfect sense. So then if that's all true, then what does that say about the curve in that particular interval? If the radius is decreasing, then the curve is doing what? Running away from this question. No.
Getting closer to 0?
Say something other than 0. Closer to the origin.
To the pole.
Or the pole, sure. Curve is getting closer to the origin, or you could say the pole, since we're talking about a polar graph. Okay. Does that make sense? Hoping that all of our work that we put into, like, what is a polar curve and what's the radius doing and all that stuff, hoping that really helps you understand why C is what it is. All right, well, we didn't quite finish, but that's all right. You can see D is about greatest distance. Hopefully that would make some sense. Yeah, it's a max. Yeah, so when I see you tomorrow, we'll get that one done, and then we will for sure get into series tomorrow. So if you don't have those notes with you, please get those out. Series is awesome. It is cool. Okay.